Hello everyone, today I want to invite you on a journey into a realm most of us pass by every day without a second thought. I'm talking about postcodes. Yes, those seemingly random strings of letters and numbers on envelopes and packages hide an intricate pattern, a hidden order that underpins the way our mail, and by extension our world, is organized. Inspired by the analytical spirit of CGP Gray, let's take a closer look. First glance, a postcode might seem like a haphazard combination, but look a little deeper and you'll notice that each element of a postal code serves a purpose. Consider the United Kingdom system. The initial letters like SW or NW indicate a broad geographic area. They tell you at a glance which part of the country the mail is heading to. Then follow the numbers and sometimes additional letters that drill the information down to a specific district or even street. This isn't arbitrary, it's a clever coding system optimized over decades to make sorting and delivering mail as efficient as possible. Now shift your gaze to the United States. There, the zip code system uses a 5-digit number, sometimes extended with 4 extra digits for greater precision. The first digit denotes a large region of the country, while the subsequent numbers narrow it down to a city, a neighborhood, and sometimes a specific post office. When you see a zip code like 90210, you're not just looking at a random number, you're looking at a map in numeric form. It's an abstraction of geography into digits, a hidden pattern that mirrors the layout of the country. But what makes these systems truly fascinating is that they're not merely about sorting letters and parcels. They reveal an underlying structure, almost like a secret code for geography. Think of them as an early version of modern data organization. Long before computers sorted through mountains of information, humans had already developed these elegant systems to manage something as complex as national mail delivery. Each postal code is a compact summary of location meticulously designed to minimize confusion and maximize efficiency. The hidden pattern in postcodes is also a study in incremental design. Consider how these systems evolved. Early postal services needed to manage growing populations and expanding territories. At first, addresses might have simply relied on names and street numbers, but as cities grew, the complexity did too. A system of codes emerged to bring order to the chaos. A layered system that begins with broad regions and refines down to the individual building. It's a brilliant example of solving complex problems with simple hierarchical data. In many ways, it prefigures how we handle data today in computer science and logistics. Let's dig a little deeper into the math and logic behind it. Imagine a grid laid over a map. Each square of that grid represents a geographic area. Each postcode corresponds to one or more squares. This grid isn't random, it's a deliberate partition of space and balances the need for detail with the practical limits of delivery logistics. In the UK, for example, the outward code tells you the larger region, while the inward code pinpoints a smaller area within that region. It's akin to a tree structured in computer science, where a large set is successfully broken down into smaller subsets. The hidden pattern is everywhere, in the numbers and the letters and the structure itself. The beauty of these patterns is their universality. Different countries have crafted their postal systems based on similar principles, even though the details differ. Japan's postal codes, for instance, also encode geographical regions, but they do so in a way that reflects the local administrative divisions and urban densities. Each system is a unique solution to the universal problem of how do we efficiently sort and deliver mail across vast and varied landscapes. And while the formats differ, some using letters and numbers, others just numbers, the underlying hidden pattern is remarkably consistent. So why should we care about these hidden patterns? For one, they are a testament to human ingenuity. In a world increasingly driven by technology and digital data, these postal codes remind us that the foundation of our modern infrastructure was built on simple, logical ideas. A reminder that even the most mundane parts of everyday life, like sorting your mail, are governed by carefully designed systems that reflect a deep understanding of geography, logistics, and information theory. Moreover, these patterns have implications beyond the postal service. They illustrate how layered systems can be used to manage complexity. Whether you're designing a database, planning urban infrastructure, or even organizing your personal schedule, the principles behind postal codes breaking a large problem into manageable pieces are invaluable. They are a hidden blueprint for order in a chaotic world. Consider this: every time you see a postcode, you're looking at the end result of a process of optimization that has been refined over decades, if not centuries. It's a small, elegant system that embodies the idea of less is more. Using a few characters to represent an enormous amount of geographic and administrative information, postal codes encapsulate a world of order in a tiny package. In many ways, they are the unsung heroes of everyday communication and commerce. In conclusion, the hidden pattern in postcodes is much more than a quirky fact about mail delivery. It is a window into the ingenuity that has allowed societies to manage complexity. It's an example of how simple ideas can have profound impacts, and it offers lessons that extend far beyond the realm of postal services. The next time you see a postcode, take a moment to appreciate the hidden order behind those seemingly random characters. They are, in essence, a secret language of geography, an elegant solution to the problem of distance and distribution. Thank you for joining me on this exploration. May the hidden patterns in the everyday remind you that even the most ordinary details often contain extraordinary secrets.